Hi, this is Maggie. In this video we're going to talk about how to create a scrolling background sprite. This program is called class-.py, and it's a very simple program with a player-controlled sprite representing a student moving up, down, left, or right within what I'm referring to as a college green. The player controls the sprite by pressing the arrow keys. The sprite stops when all arrow keys are released. Now, in this game, the window is the same size as the background, and the background is just a pygame surface that I've filled with a green color. Sometimes we want a larger background, some of which is off screen, and that will scroll if the player moves toward it. To illustrate this, I've created a larger background image with some buildings drawn directly on it, sort of like a map, so that it's clear when the background is scrolling. You can create the background from a terrain map, you can create the background randomly, you can create the background as the user moves. I'm going to load in a single image to keep this program simple and with the purpose of demonstrating a scrolling background. I'm going to rename this Python file class-scrollingbackground.py. And I'll begin by defining a background sprite class. To start, we'll just draw it at 0, 0. So to start, I'll make it a sprite that does nothing. We'll just establish that we have a background sprite and make sure the program works normally with the background sprite, and then we'll work on scrolling. So I'll define a background sprite class and initialize with the image. If I don't set the initial location of the sprite's rectangle, it will be set to 0, 0, which is fine for this demonstration. You might wish it to begin somewhere else. Down in the main program, I'll annotate a sprite for the background and the background group and instantiate those objects. I'm going to remove code that creates and draws on a surface for the background. And I'm going to remove the code that blits the background to the screen. The background will no longer blit just the once. It's going to be a moving part that we'll need to update and draw. Down under the event handling, I'll draw the background so that it's behind the sprite. I don't need to clear the player sprite because we're going to redraw the entire background every time, effectively erasing the screen. And if we run that, you can see one of the 4 buildings. The others are off screen to the right and to the bottom, as we're seeing the top left of the background. And when I move the sprite, because it's still boundary checking at the edges of the screen and keeping the sprite within the screen when I boundary check, it bounces at the edges of the screen. Okay, so now we need to write code so that if the sprite comes within some threshold of the edge of the screen, either the background will scroll, if it can, or the sprite will move to the edge of the screen. Let's give the sprite and the background a speed in their initializers so that they move at a consistent speed. Let's now write a method that asks the background if it can scroll in a particular direction. So we have the class level constants up, down, left, right, and stop. We can use those. And when we pass them in, we'll mean that the sprite is trying to move in that direction. So I'll write can scroll and pass in direction. And then we'll just see if there's any background that isn't shown in that direction. To know that, we'll need to also pass in the screen. So we can calculate what's beyond the screen in a given direction. So we'll annotate a variable result and set it to false. We can scroll up if the top of the screen's rect is less than 0. That means that the background is blitting above the top of the screen because it's blitting to a negative coordinate, and so we can start scrolling it down. And we can do a similar test for the sprite moving left. If the left of the background's rect is less than 0. Then there's background that we can scroll into view on the left. For down and right, we want to check if the bottom for down and right for right of the background's rectangle is still beyond the edge of the screen. So for example, if the edge of the screen is 640 but the right side of the background rectangle is 800, there's still background to the right that can scroll into view. At the end of this method, we'll just return result. We can also treat the background like the student sprite. So we can write a move method and an update method. I'll give the background a dx and a dy field and initialize those to 0. Then I'm going to copy move and update from student. But we're going to have to make some changes. So here's move, and we start off by setting the backgrounds dx and dy to 0. And if the direction isn't for the background to stop, then if the background is left, well, we don't need to rotate, do we? Get rid of that. Okay, if the direction is left. Now here's where it's different from student. If the student sprite is trying to move left, we subtract from the student sprite's x. So we set self.dx to negative self.speed. But if the student sprite is trying to move left, and we're at the edge of the screen, so we're going to scroll the background. Instead, we need to scroll the background right. When the student moves left, it's like the background is moving right. So these are all going to be the opposite of what they are in the student move method. And now in update, we'll still add the dx and the dy fields to the rect. But rather than keeping the background sprite within the screen, we want to keep it outside of the screen or exactly on the edge. So if the background's rectangle's right side is less than the width of the screen, that means it's moved inside the visible window. And we don't want that, because it means there's some blank space in the window with no background at all. We're going to write boundary checking that will align the edges of the background with the edges of the screen if it moves within the boundary of the screen. So now we've set up the background similar to the student. And what we'll need to do down in main is figure out which one to move based on whether there's background to scroll and how close the player sprite is to an edge. Because we're splitting the movement between two different objects, and at some point during motion we might switch which one moves, we can't simply set one in motion if the user presses a key. We'll need to keep track of the direction of motion here in the main function and check each time through the loop whether we need to send a new message to the student sprite, the background sprite, or both. So we'll annotate an integer field called direction. And inside the event handling, we'll set that field to one of the direction constants. And now, below the event handling, if direction is student.stop, we'll send the move message with the parameter student.stop to both the student and the background sprite. If not, then we'll have to check if the student sprite is within threshold distance of the appropriate edge of the screen. If it is, then we'll move the background and stop the student. If it isn't, then we'll move the student and stop the background. Let's write a method in the student class that will determine whether it's within threshold distance of the appropriate edge of the screen based on direction of movement. The method will need the screen, the threshold value, and the direction that the student is trying to move, and will return a Boolean. Checking all four directions. So if direction equals student dot up and self dot rect dot top is less than threshold, or direction equals student dot down and self dot rect dot bottom is greater than or equal to screen.get height minus threshold, and similar code for the left and right sides. Okay, so back down in main, we can call within threshold. So we're in the else of this if statement if direction equals student.stop. So if direction isn't to stop, if the student is within threshold, then if the background can scroll, then we move the background and stop the student. Otherwise, we move the student and stop the background. That's the case where the background scrolled all it can, and now the student's going to move to the edge. And then if the student's not within the threshold, then we just move the student because they're not near the edge of the screen yet. And we need to add a message to the background group to update. And if we run that, works pretty well. Student moves down the screen until he's within threshold distance of the bottom, and then the background starts scrolling up. Once the background has scrolled as much as it can, the student moves to the edge, and when I keep trying to move him, he bounces. The left, right, and top boundaries work the same if I've written the logic correctly. So that's a scrolling background. It requires a little more management than simply moving the character, but it gives you a nice effect of having a large world that the player can't see all at once. I recommend you try to recreate this program. First, just type it in, and once you have it working, try building it without looking. Once you can write the program without looking at the code here, you're ready to move on.